right, ladies and gentlemen. So today what we're going to do is we are going to continue working with ionic bonds. And we're going to be working with ionic bonds, but this time instead of just drawing them, we are actually going to go through and name those ionic bonds. So if you guys open up your assignment for today, it's called Introduction to Ionic Naming and Formula Writing. So we're going to go finding out the name and we're going to write down the formula. So you need this open. The other thing you're going to need open is, or have out available for you, is your ion sheet. So if you go to this assignment in Canvas, the other thing that should be on your assignment is an ion sheet. And in this ion sheet, maybe not. Where'd it go? Put it on the wrong day. I did put it on the wrong day. It's on tomorrow's assignment. So if you guys open it up, I'll attach it to this assignment right now. But it's an ion sheet. You might have remember seeing it from the first assignment that we did with ionic bonds. So you might already have it, but you do need this ion sheet out in front of you because we are going to be talking about ions in just a little bit. So the first thing we need to do when we're naming these ionic bonds is we are going to remember that it's always going to be the metal first, followed by the nonmetal. So for ionic bonds, it's always the metal followed by the nonmetal. And if we're looking at our periodic table, which side of our periodic table are metals found on? Are they the left side or the right side of the periodic table?
The right?
Not quite. So if it's not the right side, it's going to be the... Which side?
Then the left.
The left.
Then it's the left. So our metals are found on the left, which means where will we find those nonmetals?
Then it should be on the right.
Then it should be on the right. Perfect. So if we remember looking at our periodic table, the nonmetals are going to be all the ones on this side. And then our metals are everything on this side right here. These are all the metals way over here. Anything highlighted in purple is a metal. Everything else is a non-metal. So now we're looking at this. So we have our metal, which one of these is the metal and which one's the non-metal for this example?
Aluminum.
Aluminum is the metal. Perfect. And that means oxygen is the non-metal. So we're naming these, we're not drawing them right now, so we don't have to worry about doing all those lone pairs and valence electrons for this. So what we're going to do is we are going to write down the name of the metal as is. We don't touch it, we don't change it, it just stays as aluminum. So this one we're going to keep as aluminum. I'm going to keep this one as aluminum. Then it says, check to see if there's a need for Roman numerals. This is where we need to look at our ion sheet. So if we open up our ion sheet from Canvas, not what I want. We open up that ion sheet and we look at for aluminum. Do you guys see aluminum on this? Is aluminum on this sheet?
No.
It is not there. So if we're looking at this, these Roman numerals mean that there could be more than one valence electron, or there could be more than two valence electrons. So if we were to draw these, this copper, this Cu, has one valence electron that it's going to lose. But this copper has two valence electrons that it's going to lose. So that Roman numeral just tells you how many valence electrons you're going to lose. So there's multiple for these. So if we're looking at these and then just think about these names, keep them in your mind. So copper, tin, chromium, manganese, cobalt, mercury. And let's look at our periodic table. So if we look at our periodic table, do you see any of those elements on the periodic table? Copper, manganese, cobalt, lead, iron. Do you see any of them? Anybody see any of those elements?
Yeah, there's iron.
Where's iron?
Um,
Give me a number.
it's 8.
8. Perfect. Right here. See iron. Any other elements you see?
Copper's 11.
Copper's 11. Let's pull up that list. Copper's right here. Any other ones you see?
Lead.
Lead, where's lead? Right there. What about any other elements?
Mercury.
Mercury, awesome. Hg. So if I keep highlighting all of these, we got chromium, we got manganese, we got cobalt, we have nickel, we have zinc is on the bottom part, we have silver, we have gold, we have any other ones that I'm missing? Tin, lovely tin right over here. That looks like all the ones we have on our lovely list. So all of these, so where are most of these? Do you remember what this section is called? There's some kind of metals. Do you remember what type of metals we call those? Starts with a T. Transition metals. So these transition metals, what do we remember about them? Anything we remember about them or anything we didn't do with those ones in particular? We kind of ignored them. When did we ignore them? Giving you a hint.
They share the same valence electrons.
The valence electrons. We ignored them when we counted our valence electrons. That's because they're special, because a lot of these, not just the ones I've highlighted, those are just the ones we're going to use, but a lot of these are going to either lose 2 or 3 or 1 valence electron. So they have multiple sets of valence electrons they can lose. So if you're talking about ionic compounds and one of your metals or your metal is found in our transition metal section, we always need to check that ion table to make sure that it's not going to have a Roman numeral after it. So these are all going, or most of these have Roman numerals. When naming. So we're going to have Roman numerals when we name our transition metals. So aluminum was not one of those highlighted. So do we need Roman numerals for aluminum?
No.
No, since we didn't highlight it, it's not there. We don't need Roman numerals. So now we can go to oxygen. So it says, write the name of our nonmetal or polyatomic ion. Don't worry about this because we're not going to really use this semester. but polyatomic ions also have negative charges, but we can ignore those for right now. So we're going to write the name of our nonmetal. So let's just rewrite oxygen. And then it says that the nonmetal will lose its ending, and we're replacing that ending with IDE. So most of them, it's pretty clear where you're going to remove the ending. Oxygen's a harder one to look at because if we take this one, we're actually losing the last 4 letters, and it's going to turn into oxide. So we're losing the last 4 letters, and we're changing it to IDE to make the name aluminum oxide as our answer. Are there any questions on that? We're going to do a couple more together, and then I'm going to let you do a couple on your own. All right, so now we have our next one. It's Fe with a +3 charge and Cl with a -1 charge. So let's look for Fe. What element is Fe?
Iron.
Iron, perfect. And is iron a transition metal? Is it?
Yes.
It is in that section for transition metals, columns 3 through 12, which means we have to look on our ion sheet. So pull out that ion sheet, take a look. Does iron need Roman numerals?
Yeah.
It does. So how many Roman numerals am I putting next to this iron?
3.
We're putting a 3. And where's that 3 coming from? Anybody notice where the 3 came from?
It's charge.
It's charge. Perfect. That +3 charge tells us there were 3 valence electrons that iron was willing to lose. So that's why we have to put a 3 next to the name iron. Now this Cl with a -1 charge. What is Cl?
Chlorine.
Chlorine. And what else do we have to do to this chlorine? Do we have to do anything else to the name?
-1.
We don't have to worry about the -1 or the +3, right? The -1 for chlorine, because that's not going to affect the name. But what do we have to do to our nonmetal? So chlorine's that nonmetal. So what do we have to do for the nonmetal?
Chlorine X sign. Like you gotta put the ID.
We got to change it to IDE. So we're going to get rid of the INE here. And we are going to change it to chloride. So our final answer would be iron 3 chloride. Do you guys want to do one more together, or you guys want to try 3 on your own?
Another one.
Another one together. All right. So magnesium and nitrogen. Which ones are metal and which ones are non-metal?
Nitrogen's the nonmetal.
Awesome. We have our non-metal right here, which means this one is our metal. All right. So magnesium. Do we need to do anything with the name magnesium? Do we have to change any endings?
No, but we
No?
do change nitrogen.
We have to change nitrogen. Okay. Do we need Roman numerals for magnesium? Is it a transition metal?
No, I don't. It's no.
It's not a transition metal, so we don't need Roman numerals. Perfect. So we don't need Roman numerals. So now we get to nitrogen. And if I change the ending for nitrogen, where am I going to stop? Where do we think?
Until the O.
Until the O. So we're going to get rid of this section is perfect. And then we're going to turn it into IDE. So we're going to have magnesium nitride. Do you guys think you can try the next two on your own?
Yeah.
All right. So try the next two. So in these example 4 and example 5, when you finish example 4 and or when you finish example 5, send me your answer in the chat. Just type out the name. If you're trying to do Roman numerals for either of those problems, just type 2 I's, capital I's. Those are that's how we're going to write Roman numerals. So write out the names and send them in the chat. Let me know what you guys get. When you finish one of them, try and send it in the chat. All right, guys, let's go through the first one. So what is this metal right here? What metal is that?
Copper.
Copper. Is copper a transition metal?
Yeah.
It is. So what's my Roman numeral? Do I need one?
Yeah, it's a 2.
It's a 2. Perfect.
That's 2 charges.
It's got 2 charges. Perfect. All right. What's my non-metal?
Nitrogen, but then it's nitroxide.
Nitride. Awesome, because we removed the OGEN and we added the ID at the end. And then last but not least, we have potassium and phosphorus. What's my metal?
Phosphorus?
Careful. So if we look at our periodic table, phosphorus is over here. Potassium is over here. So which one's the metal?
Potassium?
Potassium is going to be our metal. Good. And is potassium a transition metal?
No.
No, it's not. So we don't need Roman numerals. And then we have phosphorus. And what do I do to my ending?
IDE.
IDE. So I change that to IDE and turn it to phosphide. Any questions on the naming? All right, so now we're going to go to the other part of our naming, and that's going to be formula writing. So formula writing is a little bit different than naming. So when we were writing ionic compounds based on their formulas, it's important to remember that the overall charge or the net charge must equal 0. We talked about this before when we were doing drawing. We just got to remember it when we're doing this naming stuff. So now the overall charge must be 0, so the cations must equal the overall charge of the anions. So we need them to add up to the same number, one being positive and one being negative. The way that compounds are balanced is to find that ratio or the amount that's needed for each of those elements. So the first one is done for you. Aluminum chloride is aluminum metal and chlorine non-metal. Aluminum has a +3 charge and chlorine has that -1 charge. So if we add up those two charges together, we get a +2. We want that number to be 0. So that means we can't just have one chlorine. So then what's going to happen is we're going to keep adding chlorines until we get to this 0 charge and we're happy. Once our charge is at 0, we have 1 aluminum and 3 chlorines, which is where the formula comes from. Does that make sense? All right, let's do some practice with this. So we have magnesium oxide. So what two elements are these?
Magnesium and oxygen.
Magnesium and oxygen. All right. Now, what is my charge for magnesium?
There's none.
Is it what?
There's none. It's nothing, like 0.
So there is going to be a charge. So let's remember that our charges, where do we get those charges from? Where do we get those from? How do we get a charge on an atom?
By adding or removing their electrons.
All right, we're adding or removing valence electrons. And how many valence electrons do each element want to have?
8.
They always want 8. And how many does magnesium have normally?
2.
It has 2 valence electrons. And so how many valence electrons is it going to gain, or how many valence electrons is it going to lose?
It's going to lose 2 valence electrons.
It's going to lose 2 valence electrons. Does that make it a positive 2, or does that make it a negative 2?
A positive 2.
A positive 2, because we're losing 2 negative charges, which means that there's more positives than negatives at this point. So we have a positive 2 charge on this magnesium. And oxygen, how many valence electrons does oxygen have normally?
6.
It has 6 valence electrons. How many is it going to gain or lose to have its full 8 valence electrons?
It's going to gain 2.
It's going to gain 2 electrons. And if it gains 2 electrons, does that make it a positive or negative 2?
Negative.
Negative 2. All right. So now, before we can do anything else, let's see what our charges add up to. So if we just take our charges, we have a +2 and we have a -2. What does a +2 and a -2 add up to?
0.
0. Do we need any more magnesiums or any more oxygens for this?
No.
No. So what is my formula going to be for this magnesium oxide? Or how many magnesiums and how many oxygens did I use?
1 of each.
1 of each. So I put 1 magnesium down and 1 oxygen down. Remember, we don't add 1s to the bottom because just writing the letter tells us that there's 1 there. So our formula is going to be MgO. Are there questions on this one? All right, let's try another one. Potassium nitride. What is the element symbol for potassium?
K.
Okay. What is the element symbol for nitride?
Ni.
Careful, that's going to be nickel. So remember, this is our non-metal right here. Nitride is a non-metal. So we changed the ending. So this IDE doesn't really exist. So what element has the introduction NITR or
Nitrogen.
nitrogen? So what element symbol is nitride?
N.
N, perfect. All right. Now let's determine valence electrons. How many valence electrons does potassium have? It has 1 valence electron, perfect. And if it has 1 valence electron, is it going to lose or gain electrons? And how many is it going to lose or gain?
It's going to lose 1.
It's going to lose 1, which means what's my charge?
-1.
Careful of it.
No, +1.
Electron is going to have a +1 charge. All right. And then nitrogen. How many valence electrons does nitrogen have? Not -1. So let's look at nitrogen, or on our periodic table, nitrogen is right here. So how many valence electrons does it have, or how many electrons does it have in its outermost orbital, or that last row it's in? Not seven, not seven. We're getting close.
5.
It has 5, right? Because we count 1, 2, 3, 4, 5. We don't count the 2 from this row because that's a different orbital or a different energy level. So nitrogen has 5 valence electrons. All right. If it has 5 valence electrons, does it want to gain electrons or lose electrons?
Gain
It
electrons.
wants to gain electrons. And how many electrons does it want to gain?
3.
It wants to gain 3 because it's trying to get to 8. And so if it's gaining 3 valence electrons, is it a +3 or is it a -3?
-3.
-3, perfect. So let's check our charges. We have a +1 and a -3. Do those add up to 0? Or what do those add up to?
-2.
-2. So that means we have to add more potassiums or we have to add more nitrogens.
Add more potassium.
Add more potassium. So if I add another one, I have a +1 and a +1. So now I have a +2. So what's my charge? Add up to +2 minus 3 adds up to what number?
-1.
-1. So are we there yet? Are we done?
No.
No. Do we have to add more nitrogens or add more potassiums?
Add more potassium.
Add more potassium. So I add another +1 for a total of +3 over here. So what is my total charge then? I have +3 minus 3.
0.
0. So if I have a charge of 0 for my compound, am I done? Can I write my formula now?
Yes.
All right. So how many potassiums did I need for this formula?
Three.
I needed 3 of them. 1, 2, 3. So I'm going to put a K and then I'm going to put a subscript or number, small number at the bottom, K3. And then how many nitrogens did I need?
1.
1. So it's going to be K3N is our formula here.